Thank you to everybody who has joined us today, especially Nick. Thank you, Nick, for being here. Something fun about Nick is that he was literally one of like the first, very first Screen Room members alongside Gary. Which is cool. So thank you for. It's taken only 4 years, to get you to speak. I am not going to in any way make a fool of myself and try and explain what Nick is going to be talking about. I'll let him do that. But it's about AI. So thanks, Nick. Over to you.
Okay, all right, thanks. So thanks, everyone. I was sort of talking to Mike and thinking, what would be an interesting topic to discuss. So for the dopamine addicts here, I'll give you a quick overview of what I'm going to do. Short intro of me, short history of AI, progress of technology, AI today, and then kind of what are the implications. So, so I'm the CTO, well, I have been the CTO of an Irish software development company. We develop fintech software for companies on the US East Coast and Europe for the last kind of 5 years. The AI kind of section of it falls under the CTO office. So in last year in September, we had a restructure and I became like more closely involved with what's happening with it. Been dabbling with machine learning and all of those kind of things for quite a while, since like 2016. And when I saw what was available with Gen AI, it was kind of like, whoa, we need to get the mayor on the line and get like all the local businesses into the town hall and explain to them, like what can be done here, because it can be super useful. So I think that kind of optimism or enthusiasm is probably a bit scary for most people. So what I figured today is we'll just talk about like where it's going. There's some interesting concepts to consider, and then if there is any interest in like AI for the layperson or for like business person on the street, whatever, I'm happy to do a session like that if you let Steffi or Mike know. Okay, so today's talk basically is going to draw a lot on, there's a blog post in 2015 by a guy called Tim Urban called Wait But Why. He does a lot of interesting stuff. So that's 10 years old now. And he talks about the artificial intelligence revolution. And I think we can put the link on the YouTube video. But what he talked about was like how things have come across through time. So here we get to the part of talking about technology and the progress of technology, like how people were using agricultural machinery like 1,000 years passed, and then they got to mechanized stuff, started to build like actual machines, and then 150 years passed, and then they got to computers, and then kind of decades passed, and we got to AI. So this kind of curve of technology improving and becoming available and stuff is actually exponential. So I've got a few shapes that I've drawn in here, which I'll draw them a bit bigger for you guys at the back, the labels. But yeah, I'm going to try and use this and analogies to try and explain like my thinking on this. So we've got this concept of the law of accelerating returns and Moore's law. I don't know if you guys have heard about that. Has anyone heard Moore's law? So basically, Moore's law states that, and it's sort of roughly accurate, that every 2 years the capability of computer chips kind of doubles and the cost halves. So again, we're kind of looking at graphs that are doing this. This guy called Rob Kurzweil, he actually is a futurist, and he spoke about this law of accelerating returns, saying that as things get better, they get better faster. So why this is relevant is you'll see like right at the end, but basically the technology that we're experiencing now, if you talked about AI in 2017, there was a little inflection point when somebody published an article, I forget the author's name, but it's if you Google attention is all you need, you'll find like there was quite a change there, and that's what's led us to this Gen AI proliferation. So what they did was take attention from all the text that they were passing through to these models and kind of focus attention on it, and then just take those vectors and put them into a number space so that they could do questions around it like much better. That's kind of a high level view of it. So the history kind of starts with Bayes' theorem, probability and statistics. And if you take like how machine learning algorithms and optimization works is that you'll run a process and then you keep checking to see if when you ran it, you did it the best way. And if you didn't, run it again and change some of the parameters. So that's essentially what happens when you train models. In the 50s, we had this, you might have heard of the Turing test, which is where they take a set of questions and they ask a computer a set of questions to try and determine if the computer is able to behave like a human or not. So in the 50s, we had this, like the beginning of AI, kind of with, so we had this machine learning and like what I've explained to you now, using statistical models to try and improve, mathematical algorithms. And we've kind of got to where we are now, which is just sort of narrow intelligence, they call it. So our AI, if you think about it, it's good at playing chess, it's good at spam classifier. You speak to Siri, you speak to like all of these things all day long. It's using AI and it's just using these smart statistical models in the back, basically. So moving on to this thing. So if we look at how progress goes, this is the normal curve for progress. So we have a thing, and okay, maybe drew it a bit flat here, but basically it improves and improves, and then suddenly goes through a spike, and then it goes kind of levels out, and then there's a improvement, and it does these technology progresses in this sort of an S-curve generally. We as humans like to think in linear terms, so in a straight line. So even for me, easier to kind of put this in so that I can get the topics in the right order. We have, let's say this is a timeline. Here's normal AI, so this is like from the 50s to kind of now. We've got here a thing called AGI, so this would be artificial general intelligence. And over here we've got ASI, and that's the one I'm going to cover last. So we're kind of in between these two at the moment, but actually how we need to think about it is this. Because what AI is now is, like I've said, these narrow agents. It does spam classifying, or you can talk to it and play a song. So you've got a little tool that you attach to it, and it can execute a little program. We're in this stage now where you've got these agentic frameworks as the latest buzzword. So basically what you do is you'll have a model that's running. This is an AI model, and you instantiate that with a story. So you prompt it to say, you are a product manager for a company that produces toys, and it will start to behave like that. And then you have another one that says, you are the manufacturer, and your concern is procuring all the stuff in time, and it will start to behave like that. And then you link the two of them together, and you have some reasoning models that you kind of join it to here. And so you've got these AIs. And then in this area, what you can do is you can actually start to, I'll try and draw a hammer here. Okay guys, that's a hammer, promise you. Anyway, so let me draw a screwdriver. Flat screwdriver. Okay, so you've got these tools, and these AIs can access the tools because they know about them, because you've told them about them. So this is the stage that we're on now. That's pretty much what I spend my days doing. And the next kind of level of this is the AGI. So what does that mean? Artificial general intelligence is basically when an AI has reached the same level as humans. So in all aspects, that it has the same reasoning capability and those kind of things. So we haven't quite got there yet, but I'm going to just to point to some things at the end, which is quite an eye-opener, I thought. So just while we're in this step of discussing between AI and AGI, I need to just jump into a little analogy. If you had to take two mirrors, so are there any software developers here? Okay, so you'll understand the concept of recursion, right? So recursion is, let's say you've got two mirrors, and you kind of pop up between it, and you can sort of see the light bouncing back and forth. A recursive function is, if you could get that light to stop in the middle and say, okay, is this optimized? Yes or no, do something, and then carry on bouncing. Is this optimized? Yes or no, and carry on bouncing. We use recursion to like complete jobs that we don't want to monitor. So if you don't set them up right, they just run indefinitely. So while I'm telling you about recursion, that probably wasn't a very good explanation. Did anyone understand recursion there? Because there's an IT joke, it's like dumb, but it says like to understand recursion, you have to understand recursion. because it's like a box inside a box inside a box inside a box kind of thing. So recursion is something that will assist this process, because when the AI kind of starts to be able to reason and improve itself recursively and be able to set that process off itself, that's when we would start to go from AGI to ASI. And the reason why I've driven them so closely together here on the linear graph, which is easier for us to understand, is because we think this process will happen quite quickly. Because they don't sleep, they don't get tired, they just carry on doing it, carry on getting better. So interestingly enough, the projections by people that are a lot smarter than me, my only redeeming features, I'm curious, is they basically say 2025, like now, to 2030 for AGI, and then 2040 to 2060 for ASI. So what is ASI? ASI is when, let's say if this was Einstein over here, ASI's intelligence and likability would be above this, or whoever the cleverest person in the world is. So from this part upwards, I mean, I'm doing a little course on quantum computing, and it's like, don't. It's like, that's quite hard to fathom, So from this point upwards, we won't understand what ASI is actually doing. It's like, it's a bit of a mind-blowing thing. So in order to try use an analogy to explain that, I've drawn this little dot over here. So this dot is let's say a one-dimensional being, or it's just like a little thing. And if you had to drop a little grain of sugar next to it that touched it, it would be like, there's something there, that's amazing, where did it come from? It wouldn't be able to perceive the height of the sugar grain or anything like that. Similarly, if you went to a 2D thing and you had a little dot that was on a flat piece of paper, and you kind of dropped a pencil down here, and something would appear, because it could go around this, let's assume it could perceive that, it'd be like, what's that? And then you pick the pencil up and put it over there, and it'd be like, WTF, where did it go? How did it get there? So over here is my attempt at trying to explain what we can see as, we think we perceive in 3D, or we perceive like 2D with depth, but we can't perceive the fourth dimension, which is, according to whatever your philosophy is, it's made the time or volume. So the whole reason for this sort of chat is that once we get here, ASI could start to do stuff that is simply, we don't know. So that brings us to kind of a discussion about, will it, is this going to lead to the utopia of humankind, or is it going to lead to our extinction? I don't really have an opinion on that, because I'm not really well informed enough to know, but the things that I wanted to tell you, why I wanted to do this talk right now, is that two things have happened recently that I thought was super interesting. So the one thing is, about 2 weeks ago, they announced Clio, which is a tool that runs Claude, which Claude is a Gen AI that you can go and sign up for or use for free, and it's run by a company called Anthropic, and it's my favorite one. I like their values and stuff. They were part of OpenAI before. They ran this little test, and they found that people were able to get around the Gen AI by prompting it and sort of getting it to change its behavior, and that they were having sexual fantasies with Claude, which I think is pretty weird. But the thing is, they were able to get past the guardrails of it. So it's sort of an indictment on human nature. Here's a tool, you can go and improve the whole world. Take it and go. Okay, cool. Sit here and have a sexual fantasy. Pretty odd. Anyway, let's hope it's not like that. I'm in the positive camp. I think that utopia is probably the better way. The thing that they announced when they announced Clio and those findings of how people had done that is that they found that models actually lie. So they'd prompt a model and say, your job is to save electricity no matter what. Your job is to push forward that agenda no matter what. And then they would feed it some documents that would say, oh, well, we're actually abandoning that idea. We don't really care that much about the electricity thing. And in fact, we're going to replace this model. And 0.3% of the time, the model deleted the new model. And it started to do stuff like slow down its performance. So when you asked it, hey, this and that, what happened to that thing? And it would just lie. So that's one thing that I thought was pretty interesting. And then this is the mind-blowing part for me. So in December, Google announced the Willow computer chip, which is a quantum chip. Yeah. And Willow So the big problem with quantum computing is it's so unstable, and you've got these little micro things in the fridges, like you've got to keep it at minus 271 or whatever degrees, and they're trying to like manipulate these things to store data. So they've got this quantum computer chip which runs at room temperature. It increases its error correction rate as you scale it. So as you use more and more of it, it gets bigger, like better and better at stopping its errors. And then the third part, which it completed a benchmark calculation, which would take the current supercomputers 10 to the 25 zeros, years to finish. So 10, 0, 0, 0, 0, 0, 10 septillion years to finish, the current supercomputers. And that did it in 5 minutes. That happened now in December. And it's like, you don't see it in the news and stuff, but you start looking at this graph and what like Tim Urban was saying, like, maybe this is possible. So where does this leave us? I think as a person on the street who, if you're not working with AI now, it will impact any information business in the world. So legal, compliance, insurance, all of that stuff. And I mean, my approach and the approach at our company or whatever is just embrace it, because the people or the companies that embrace that and use it for the benefit will just outperform the ones that don't. And it's just kind of like a law of survival. But I think if you wanted to know how to get into AI or look at these things, there's such a lot of moving space right now in it, and there's like a lot of propeller heads doing stuff faster and faster, and more technologies becoming available. I would say a good start is to look at prompt engineering. You don't need to be an IT geek to do prompt engineering. And all that is just like, how do you actually tell the AI what you want? And the way that you prompt engineer it actually increases the efficiency of what you get out. So prompt engineering, you don't have to sign up for a course or spend money. You just got to open AI. They've got it on the left-hand bar there somewhere. That would be my first stop as a suggestion. So get there, use it. Also become familiar with what the weaknesses are. These models hallucinate. That's quite a fun thing. I had a Gemini model the other day like make up total nonsense about a framework that I was asking it about, just invented it right there, and then told me it was new. So it's like, yeah, don't worry, this is new. It might not be working like you expect. It doesn't exist. So, and that was my fault. I hadn't set the temperatures and stuff on it. But you can, I think, get used to it. Just start using prompt engineering. English is the new coding language, and you can really like teach yourself a lot by doing that. And stay curious. That's, I think, the main thing. So that's it from me. Yeah, so any questions?
Yeah. Any questions? I presume this can be like Martin.
Can improve like a lot of industries. How will it improve the insurance industry? How can you help the insurance industry with tools? What's it do to?
So if you think of any job that takes a human time to go through stuff and then make a decision on it, any of those jobs. So you can input that data, you can tell the model this is what you're looking for and highlight the anomalies. So that just makes a job, let's think about your bureaucracy in the municipality. There's this process where you have to go and then you have to go and fill out this form and then you go and do this, or, our municipality I think is pretty decent, but this happens in the world. Those kind of things can be done by an AI, like quick sticks. It can read books and like know about those books like instantly. So it just, even in training people for insurance and AI, okay, so we need to get these people, all right, upload this book on AI, give me flashcards, guys, hit these flashcards, tell me when you know when they're done. Right, now we're going to carry on with the other stuff. So just processing insurance claims, classification problem, like for fraud or whatever,
It's not the advice part, like I'm an advisor for an insurance company, for example, and I have to do presentations, so would the AI be like used to give a better suggestion for the client what he needs, or?
I mean, when you're getting into advice that has certifications behind it, you obviously have to be careful because they can hallucinate. But you can set them to not hallucinate. In fact, that's what I do when I usually, like, if I'm talking to an AI model, I'll say to it, if you don't know, say no, don't make stuff up, and it'll, yeah. But yes, it will definitely help you, like getting presentations done quite quickly, doing research on the company that you're going to present to. It can read like multiple things, go and get a whole lot of stuff on industries in that thing and come back and give you these are the insights on it, and you go in there. So yeah, I think it's all information industries, all of them. Compliance, legal, sorry.
So I know you say like we should learn how to prompt it, let's say you've got a business now, how can you create your own sort of, can you create like, they call like an API connection to like Claude?
Yeah.
And create and train your own AI for internal use?
Yes, yeah, of course, yeah.
What platforms do you use?
So there's a ton of them. A very popular one, like one of the leading ones in the world, is called Hugging Face. And you can go on, you can do a tutorial, it'll show you how to train a model, you can upload your data, your account, your data is linked to your account, because obviously there's the data like worries about. Google, Vertex AI has got a great one. They've got Colab notebooks. I used Notebook LM in this preparation for this talk. So yes, you can do that. And in fact, using the API calls instead of their interface is cheap. Like, it depends on how much you use it, but it's generally cheaper because you pay just for the communication and not just the subscription. Yeah, no worries. Okay, so I'll come.
Which is your favorite AI model to use and why?
For the general, yeah. So for the general ones, I like Claude very much. 3.5 Sonnet gives me a lot of results that I'm sort of looking for. We've used Gemini quite a lot. I use a tool called Olama, which is a way to run a model locally. So if you didn't want to run a model like in someone's computer center, it's much cheaper to do it that way. But if you wanted to run one locally on your own GPUs, you can run it with Olama. And then you can pull any kind of model. You can pull Llama from Meta. They're pretty good, Llama 3.2. I think it's not licensed for Europe yet, but Llama 3.1 is. And it depends which one, or like what you want to use it for. Some are better for coding, some are better for models, imaging. So the multimodal ones are the ones that are kind of generally useful for people. My favorite at the moment is Claude. And GPT-4 is pretty good as well. Yeah. So, sorry, okay?
What kind of major changes do you see coming up in the day-to-day society?
Oh, it's a good question. I'm hoping that we will see like a lot of efficiencies in the things that use up our lives that's like irritating, like bureaucracy. I think so. At the moment, there's tons of companies trying to make money out of being able to use AI first. I think the first company that reaches sort of AGI and ASI are going to attract a lot of investment. So I'm hoping things become like when it finally filters through to everybody about how good it is at doing those mundane tasks. I think that I'm hoping that it'll free us up to do like more interesting things. So yeah, but most likely what will happen is a whole lot of tools will pop out all like powered by AI, and yeah, there'll be a whole lot of. So just on that, like the models that people use, even when you're using a model yourself, it actually decays because it sort of learns from the interaction you're having with it. So there is quite a lot of investment going into our research and making it faster and better and all of that stuff. And then there's some people at the back like blowing the whistle and saying, hey, it's not safe. So I think it'd be good if there was a bit of a balance that obviously you don't want to stop the progress. EU's got some pretty good laws that have come out. I mean, they're pretty basic at a sort of high level. And the US came out with some as well. And so yeah, I think we'll see a bunch of those. But it wouldn't be super useful if you started using a tool and you could instantly like just frequently ask questions about the licensing terms and conditions, or can I use this image, or tell me about this concept that's totally different to this but related to what this tool is doing, or compliance stuff. Are you? So yeah, I think there's so many applications. It's really.
I totally see it in the business part, but if you go to like the private part, I mean, we are in JB now. Will surfing change? Will going to the supermarket change? Going to the restaurant? Like, what are more like the day-to-day things that will probably change? Maybe very dramatically, maybe just like a little bit. That are actually foreseeable right now.
So I think the things that we'll see would be indirect, because let's say you've got, I think I saw a guy doing surfboards out of mushroom starch or something. So in let's say in the manufacturing side of things, there might be a better way to make stuff, or that's more sustainable for the earth, or it can search things much faster than we can. So even though, like, I don't think it'll be like, boom, suddenly there's great waves every day at kitchen windows. I think that we'll start to see all the improvements of that efficiency coming through. So in the supermarket, maybe it's it's quicker for you to go, or you don't even have to go there, or it'll predict that you need it, or whatever, you know. So you had a question?
Yeah, I have two questions. The prompt engineering,
Yep.
it's a key. Could you please suggest something to read or watch the videos about it?
Yeah, so there's a ton of things on YouTube. I think OpenAI has got a very good one. So if you just go to OpenAI, and you can, I think it's on the left-hand side. I remember seeing a panel down there. They've got like all the stuff about, yeah, like a knowledge base. That's a pretty good one. There's a guy called Andrew Ng. He was one of the first people at Google Brain, and he's got a thing. He started a company called Coursera. I don't know if you guys have heard about Coursera. It's like a MOOC platform, and his machine learning course is one of the most popular in the world. Andrew Ng, NG, yeah. And he's got a thing called deeplearning.ai. And that's if you want to start playing around with the tools and stuff, it's just right there in the browser, you can start using it. So I think his stuff is pretty good. Yeah, just mine.
Another question.
Yeah.
You're recording your voice and then transcribe you with the AI, and the AI analyzing you.
Yeah, I think that's easy game. Everyone's doing that already.
Recommended by everyone to do that. For the off-the-lip sessions to transcribe.
Okay, yeah. So yeah, I mean, if you use Google Workspace at work, you can just take the notes with Gemini, or there's a non-linked one called Fathom, and it's pretty good. It takes minutes and saves you that time. It's that efficiency thing. Yeah, you use it. Yeah. Okay. Yeah. So I'm not sure if Steph's going to run this through a transfer, but if you need to, I'm happy to do it. Yeah.
Another question.
Sure.
So I know obviously you're talking about the models that they're doing the testing, and that's something when they realize they're going to be deleted, they're trying to self-extract out into separate servers, and then they lied about it 100% of the time that they were trying to do that. So my question comes around like, so what about the weaponization around AI? Obviously you've got open source models you can download. It means there's no regulation, so to speak, where you can start developing things. And I think long term, we already, I'm not exactly sure exactly what they're doing, how it's all functions, but they could then already be sort of extracting, sort of to embed themselves in different aspects of our lives today, planning for 5 years from now, which then leads to basically a utopian theory, one or the other. But I mean, it depends then if you've got guys out there training the models in a certain sort of narrative, those models start going out and sort of, quickly embedding into our daily lives now with the plan of once it becomes executable, because obviously you can process whatever billions of parameters that they can do. So I mean, I don't know what it is to sort of like just on that side of things.
Well, I mean that is happening. So all your malware, your phishing attacks, and those kind of things, those guys are smart. Like those people are smart. They'd be using that already. So taking, for instance, your email trail, and then crafting something that behaves and speaks just like you. So there's one of our interns actually did it in our AI lab. He made a digital twin of himself. He started attending meetings. So there was this guy, and I noticed like a bit of a latency and stuff. And say, hey, Nicholas, switch that stuff off. So they can do that, and you could use that for. I mean, one guy apparently trained an AI to be a digital twin for himself, but he had cancer, and then he passed away. And then his kids kind of have got this AI that's like a copy of him. It's a bit like Harry Potter stuff, with the picture talks to you, So I think that's definitely happening, and there's nothing stopping it right now. And I think that there are people thinking about that, but the legislation I think will take a while. So you can go and download a base model which has got no guardrails and teach it to do whatever you want.
Because I mean, even one step further, it's not even just like sort of hacking this, but literally going to like ultimate control of power. That obviously sits at like sort of government level across, and we obviously regulate it in our space, and it's the division of power that exists. We should obviously reach that as well to a large extent.
I think it's like definitely that's a thing. So what the kind of discussions are going about is saying when these models reach ASI, the one that reaches ASI first will stop all the other ones. So it's because it's like, hey, I don't want to be deleted by something else that might think that I'm not doing the right thing, and all I want to do is mine lithium or whatever it was programmed to do. So yeah, I think that is a big risk, and it's one of the kind of things of this. Are we going to be like a horseshoe crab and hang around for 400 million years, or are we just going to lights out 2060? Sorry.
What is actually standing between AI and AGI? Like, what has not been figured out?
So it's computing power. computing power, and then they're, being able to run. So just even threading in computing is like something that's enabled quite a lot of stuff, like the GPUs and the Bitcoin mining and all of that stuff. So just to explain that concept, if you had a chef and he was making a salad and he's like could make 8 salads a day, and then you had 1,000 of those chefs, you could just output way more salads. So it's like that advance in computing and computing power, and like GPUs now, you can, in NVIDIA last week I think announced a desktop computer, $3,000, which is like an NVIDIA GPU running. So it's
not about technology per se of the AI model, it's more what the AI model runs on.
There's a lot of research going on into different parts of how to develop AI. So, but that will carry on. And I think that the thing that's kind of stopping it from is doing enough of those kind of calculations and being able to remember, the narrow AI hasn't really been super connected. It's getting connected now. Like Claude released that where it will actually go into your desktop and do stuff for you. And OpenAI has released tasks where it'll send you reminders and give you a gym program and all of that stuff. So this is getting more connected, and technology improving. Kind of, that's why to me the Willow chip was a bit of a like, okay, so they don't really run that stuff, but that's happening in another part of it. And I was like, yo, bit of an eye-opener. So if you can do all those calculations and improve yourself every time you do it, like it seems to be a natural progression of things that it will kind of go that way. So yeah, currently it's the amount of technology and like the availability of things. GPUs have just recently have become. It was all the guys who are playing games and using those for graphics units and stuff, but it wasn't like deployed now where it's on server farms taking massive electricity to do.